let's go ahead and do a few more. So this next one I have, we are going to have to do substitution method for this one. There's actually no other way. There's no elimination method. And since there's no squared, x squared, or y squared, I'm actually going to go ahead and solve for x or y on the following. So I've got y is equal to negative 6 over x. And now I'm going to go ahead and substitute that in to the bottom equation. So x squared plus negative 6 over x all squared equals 13. So that will give me x squared plus, well, negative 6 over x. If you square that, it gives you 36 over x squared. And that's still equal to 13. Most people do not like fractions, and I'm sure you are among those people. So if that is the case, go ahead and just multiply both sides by the denominator of the fraction that we have, and then just distribute it to every term, both sides of the equation. So x squared times x squared is x to the 4th. X squared times 36 over x squared is 36, and that all equals 13x squared. Once again, we have multiple x's, so I'm going to get this all equal to 0. And I am going to factor. So factors of 36 that add up to negative 13 are negative 9 and negative 4. And since it's x to the 4th, which is a quadratic form, we're going to have x squared minus 9, x squared minus 4, which both of those are differences of perfect squares, so I can factor those even more. All right, at this point, I'm going to go ahead and set all of those equal to 0. So I've got negative 3, positive 3, negative 2, positive 2. So a lot of answers. And let's go ahead and find our solution for each one. So x equals negative 3. I'm just going to use this equation right here. So y is negative 6 over negative 3, or 2. So we have negative 3, positive 2. Then I'll do x equals positive 3. So y equals negative 6 over 3, which gives you negative 2. So you have the coordinate 3, negative 2. Then we'll do x equals negative 2. So y is equal to negative 6 over negative 2, which is positive 3. So negative, 2 positive 3. And hopefully you're kind of noticing a pattern, but that means when you do x equals positive 2, you'll get 2 negative 3, because y is negative 6 over 2, or negative 3. And those are your 4 solutions. Once again, you can go ahead and check all 4 by plugging them into the bottom equation. They do all work. So I'm going to skip that for this one. All right. But just remember, square roots are usually where you get your extraneous solutions. I'm actually going to go out of order. I think I might not even do 6 because it's basically the same idea. Just do substitution. But 7 and 8 are tricky ones for people, so I do want to make sure I cover that. So for both of these, they stump people because of the logs. So let's just review some tricks of logs, some properties. One of the properties of logs that will help, because we're going to want to use substitution method, is to know what to do with a coefficient. So if you see a coefficient, you actually can move it in to the argument of your log and write it as the exponent of your argument. So these are your arguments right here. To get rid of natural log, remember it's base e, so you end up with x is equal to y to the 3rd power. Oh, sorry, I put 3. And that is definitely not a 3. Sorry, that is a 4. Perfect. So we've got x equals y to the 4th. So now we're going to go ahead and do a substitution. we'll put this y to the fourth in for our x value. So we've got log base 3 of y to the fourth equals 2 plus 2 log base 3 of y. So, in fact, actually, before I do that, let's just go ahead and move that one in too. There's a lot of ways you could do this. I'm going to move that in. Now, I'm going to go ahead and get all the logs on one side because this 2 isn't inside a log. So, I'm going to go ahead and subtract log base 3 of y squared. And when you subtract logs, the other property to remember is that you actually end up dividing. You can combine them by dividing your arguments. So that's the same thing as log base 3 of y to the fourth divided by y squared. That's all equal to 2. And then if you recall, you can get rid of a log by matching the base. So 3 raised to the log base 3. Because those are inverses, you end up with y to the fourth over y squared, which simplifies down to just y squared. And 3 squared is 9. And then we take the square root. You got your positive and negative answer. So you get plus or minus 3. Now, before we actually go on, because we're dealing with logs, you can actually identify extraneous solutions really quickly by identifying where that y value is. So the y value is in the argument right here. And you need to remember that the argument always has to be greater than 0. A I'm putting for argument. So that actually tells me that negative 3 is not going to work. I'm just going to write that down. So negative 3 is extraneous. So we're only going to use y equals 3. And we can find the x value by plugging it into here. So x is 3 to the fourth, which is 81. So our solution is 81. Oh, sorry. I'm going to write it here. 81 comma 3. Remember, do the x value, not the first number you found, but the x value first. Okay, let's go ahead and go to another log one just because it freaks people out. They're not as bad as you think. By the way, so on the homework, your log problems can have some decimals, and that's okay. So this one, good one, both of them have log base x. So there's no properties where I can move exponents in or subtract anything. So I'm going to go ahead and just get rid of the logs by putting a base of x on both of these so that you get 2y equals x cubed and 4y equals x squared. Now, substitution's kind of cool. We could do substitution method for this. So I've rewritten both of these equations. You'll notice that 4y is the same thing as 2 times 2y. And that's equal to x squared, right? Well, this is a 2y, and 2y is x cubed. So I can put that x cubed in for the 2y, and you get 2, no highlighter, 2 times x cubed equals x squared. So there are multiple x's, so we're going to get this all on one side. So 2x cubed minus x squared equals 0. We're going to factor by taking out an x squared. You get 2x minus 1. So this would give us a repeated solution of just 0, which I don't need to write twice because there's 2 of them. And this one would give me a solution of x equals 1/2. And with logs, once again, you can identify extraneous solutions pretty quickly. So we look at so we found x's, and the x is in the base. And if you remember about bases of logs, the bases also have to be greater than 0. So they can't equal 0, meaning this value, 0, is extraneous. And we only have to deal with the 1/2. So let's pick one of these easier equations we came up with and plug it in. So we've got 2y is equal to 1/2 raised to the third power. I'm going to put that right there. So 2y, 1/2 to the third is an eighth. So y, if you divide by 2, it's the same as multiplying by a half. You get 1/16. So our solution would be a half and then 1/16.